we're going to look briefly here at solver SOPs. So what a solver SOP does is it actually remembers previous frames that have cooked, or usually stores just the one previous frame. But it caches it, and it allows you to actually build upon a history of what's happened, unlike the standard SOP network here. If I plug my grid right into here, what you'll see is we get a time dependency. And as I scrub through here, we get this blue highlighting over the time bar, time slider. And what the blue highlighting means is it's showing us that these frames exist as a cached simulation. So frames 1 through 25 are here in memory and have been cached through this SOP solver. If I click reset simulation, you'll see that anything past my time slider disappeared. It caches very quickly because there's nothing happening inside here. But if I go back to here and click that, we only have our first frame cached. So let's take a quick look at like a practical example here. I'm going to put down a mountain SOP here. And let's give our grid some points. Let's make it pretty dense, like 50 by 50. We will take our element size and we'll make it pretty strong. Let's say 3. And our amplitude. Now, if we animate this amplitude, all that's going to be happening is we're just going to be growing or scaling that mountain pattern, but it's never building on the results from the previous frame. And we can see this. I'll set keyframes here. I can just set 1 here and 1 to like 3, right? It's a traditional animation. It's just inputting this value and driving the mountain with that value. But it's not actually aware of any history, and it's not building off of what happened before. Now let's take this mountain here, and I'm just copy pasting it and deleting our keyframes out of there. Let's give it a kind of a small value, something like 0.2. And I'm going to copy and delete it, and I'm going to paste that right into the solver SOP here. And we'll wire our previous frame right in here and then go into out. Now, before I move forward, let me quickly explain what's happening. This node gathers the output of our network here. It gathers the previous frame that was coming in. So whatever came out here gets the previous frame. And then we do something, and then we wire that back out. And then here we have our inputs, various inputs that can come in. So those are these values here. Okay, so all we've done is we've taken the mountain, we put a small value on it, and we've said, please apply this to whatever happened in the previous frame. And now when we start playing this, we see a much different result. Now you'll notice the geometry gets pretty janky. And this is where things, yes, that's a technical word for it, janky. This is where things get pretty interesting because we can manipulate geometry and do all kinds of new stuff, including creating new geometry inside these networks here. So one interesting trick is to do something like a remesh, which will do a triangulation of whatever nodes are coming in here, whatever geometry is coming in, and you have some controls for controlling the density of that in here. So we'll leave it fairly middle of the road here like that. And now what's going to happen is no matter what is happening here in our previous frame, we are always going to remesh that geometry so that we're getting a uniform division of geometry here. Then we'll apply a mountain, and then we'll go out from there. And now when I play this back, what you'll see is we will get places where the geometry is turning inside out, right? Penetrating through each other, because we're not doing any sort of collision detection in here. But we're no longer getting that weird stretched out geometry that we were before, because essentially we are finding a smart way to resample and remake that geometry every single time that we park on a new frame. And now we get some really interesting simulations this way. In fact, we've just created our very first simulation, and it took almost no effort on our part. And what's cool at this point is, I mean, you can do anything inside these networks that you want. You just have to remember that what it does is it applies it to whatever happened on the previous frame. But we can do things like adding animation in here. So I can choose to animate that and maybe give it a longer pulse duration, maybe pulse duration of 3. And if you get this little warning here, just click Reset Simulation. And then as I step through here, we should be seeing that there's some subtle movement happening in the noise. Right? Pretty cool stuff. If you're wondering, by the way, why is this surface blue? By default, the viewport is configured to color back faces blue, but that can be disabled in your preferences. There's a viewport button right here that will disable the coloring of back faces. But very cool to be able to do something like this very quickly. Now, you can get very, very complicated with these things. You can build particle systems. You can build your own fluid solvers. You can build anything that you can really imagine. The tools are all here for you inside this network. And it's up to you to put whatever it is that you imagine and dream of inside here.